When we're finding the surface area for a pyramid, we have to realize that there are actually two different heights at play. We have the height of the whole entire pyramid, which we usually denote with the letter H. It would be this perpendicular height here from the vertex down to the base, making a right angle. Okay, and then we have a slant height, which is basically, especially if you see over here in the other net picture, it's the height of one of these right triangles that form the lateral surface here. We're going to use the letter L for that, like the L in slant height. Okay, so when we're finding the lateral and total surface area, which one of those do I use? Am I going to be using the regular height H or the slant height L? Fantastic question. Let's see if we can address that, shall we? All right, I'm going to come back over here. Maybe scroll down a little bit. Let's draw ourselves a net for this square prism. It has a base shape that's a square. Hey, this one's green. Why not? Why not? Let's go with green. So we'll start by drawing a square base. And then we have triangles that surround it for the lateral surface. So I'll just draw some triangles in each one of these faces. It's exquisite. It's like it was computer drawn. All right. Now, for this particular net, I can't even see where the height actually is, like this height here as H. It's coming out at us on the screen, and it's not actually represented any place on the net. But which one would be the slant height here, because it is the height of one of these triangular faces here. So I'm just going to put this here as an S. No, I'm not. I'm going to put it there as an L, yeah, for slant height. And then since this is a square here, we know that this is S times S. And let's find our surface area. We'll start with the lateral surface area here. Lateral surface area. This right here was the word surface, though it didn't look like it. So our surface area should be equal to, well, I just need these four triangles, right? I just need to add up these four triangles here. Do they need to be shaded? Probably. How about this lovely seafoam green part? I need to add up all of these things. There we go. Now it's looking really sharp. I got four triangles. Right, so here's my strategy, four triangles. How do you find the area of a triangle? That's 1/2 of the base length times the height. Not to be confused, the height here, this little h, is not to be confused with the height here for that thing. It's the height of our triangle that goes around the perimeter of the base there. So that one's L, right? And then what's our base here? Our base here is this S. So we're going to do some substitution here. We're going to have 4 times 1/2. The base length is an S, a little s, and our height here is our L. Now, since this is all multiplication, which is commutative, that means that I can rearrange it in whatever order I want to. So I'm going to rearrange it thusly. I'm going to take the 1/2 and bring it on the outside. Then I'm going to pair the 4 up with the S. Why am I doing that? Secrets to be revealed. 4S, and then I'll multiply it times the S by the L. Yeah, I did that because maybe you recognize the 4 times S as something. What does 4 times S equal to? Isn't that the perimeter of a square? It is. So I'm going to take this 4S out, and I'm going to replace it with the perimeter of the base, 1/2 P times L. And that is the lateral surface area formula for not just this one, not just a square pyramid, but all of them. It would work exactly the same way for this hexagonal pyramid, because you would have, same kind of deal, for your surface area. You would have 6 triangles this time. Each one is 1/2. It says base on this one, so okay, fine. We'll use B for base, little b. And then our slant height for the height, right? And then just do a little bit of rearranging here. 1/2 times 6b's, and then multiply that times the L. The 6b's, that's the perimeter of this hexagonal base. So it's also equal to 1/2 perimeter of the base times the slant height. All right, so one last thing about this, maybe I should go back over here first so I can draw this in physically. It's going to come up again on the cones, and I will draw it in a obnoxious color that we can definitely see. The height here, and together with the slant height, if I connect the two bases here, I make myself a right triangle. And that's important because if I don't know the slant height and I do know the height, we can just use the Pythagorean theorem to solve for the other one. It will come up, I promise. All right, coming back over here, let's take a look at the surface area of a pyramid. Just any pyramid, S for surface area. This is lateral surface area specifically. 1/2 P times L, where P is the perimeter of the base. L is the slant height. And what would I have to do in order to find the total surface area? Well, this one only has a single base on it, so I would just have to add in one base. What do I call the area of the base? Capital letter B. So the total surface area, 1/2 P times L, there's the lateral surface area, and then just add in the area of one of the bases, because it only has one.